Hello and welcome back to Switch and Lever. Today we're making a miniature tilt head for your tripod. It's a great tool for smaller tripods or monopods, and it gives you that little bit of extra articulation which you might have been looking for. Not to mention it's a great exercise for those learning machine shop basics, as it deals with tight tolerances, some interesting work holding, and a variety of different tools without being a needlessly hard project. So let's get going. First, we start by preparing our workpieces by milling down 2 blocks of rough cut aluminum down to size. Next, we'll need to mill out a circular recess at the top of one of the blocks, and to do this, we'll use the help of a rotary table and a small chuck. By clamping a pin, in this case the shaft of a broken end mill, and edge finding that, you can easily dial in the center of your rotary table. Because the block itself isn't square, we shim it with 2 pieces of aluminum to clamp it properly in the center of the chuck. We also add some thin brass shim stock to prevent marring of your recently milled surface. Mount your end mill and start milling from the center out until you reach your desired diameter and depth. This circular recess will hold the thumb wheel, which helps you attach the camera to the top of the tilt head. Drill a hole in each corner and tap to an appropriate size. These will be used to screw down the cover plate for the thumb wheel. But let's start work on the actual thumb wheel. Using a piece of thick aluminum rod, turn down the outer diameter to be slightly smaller than the inner diameter of the recess you milled out in the block. After, turn down the end of the rod to a diameter matching tripod thread, which is an imperial thread called 1/4 meaning 1/4 of an inch in diameter with a pitch of 20 threads per inch. While it's a common thread in the States, if you're doing this in part of the world where the metric system is used, you may need to special order the tap and die to cut this thread. Don't forget to turn down a thread relief where the smaller diameter meets the larger, and chamfer all edges before parting off the thumb wheel to length. Turning the thumb wheel around, mount it in an indexing head in the mill. Using a small engraving cutter, cut grooves every few degrees to create a nice gripping surface all around the thumb wheel. Since the edges the cutter leaves may be a bit sharp, take it back to the lathe and deburr with a sandpaper. Put the thumb wheel in a vise with soft jaws and carefully thread the end. Make sure you keep your threads nice and straight. Unfortunately, I did not, and this thumb wheel had to be redone from scratch. I will, however, spare you the footage of doing all of that again. Back in the lathe, chamfer the edge of the thread and clean it up with another pass of the die. Now it's time for the plate, which will hold the thumb wheel in place. Using aluminum plate, mill down all sides to the correct dimensions. As I did not have a parallel thin enough to slip under the plate in the vise, I ended up using 2 parallels and clamping around those, as that left a gap between the jaws of the vise where an end mill could fit without interference. Drill holes in each of the corners to match the tapped holes you put in the block before. Drill a bigger hole in the center of the plate to give clearance for the thumb wheel thread. Countersink the holes to make sure the coming screws will sit flush or slightly below the surface. Test that everything fits and then move on to the next step. Drill a hole at the center of the bottom of the other block of aluminum. Tap this hole with a 1/4-20 tap. Flip the piece onto its side and drill a bigger hole straight through the block. This hole will fit the axis bolt, which we will make later. Mill down the sides equally until you create something like an upside down T shape. The bottom piece is now almost done. Also remember to drill the other block at the same position. Again, we go back to the rotary table, and now using a dowel we find the center of the table. Using a custom-made dowel which matches both the hole in the rotary table and through the holes in the 2 aluminum blocks, we can now easily clamp down the block to the table while keeping the center of rotation at the holes in the blocks. Insert a spacer onto the dowel and then your block. The spacer is there so you don't mill down into the table. Using a strap clamp, clamp down the block to the table, making sure you align the block properly with the T-slots in the table. This can be adequately done by putting a spacer with the same width as the slot and leaning it against your workpiece. Mill out the bigger radius, taking repeated light cuts until you reach all the way around to create a nice half-circle radius around your block. Rinse and repeat for the other block, this time using a higher stack of spacers to fill up the empty void under the workpiece. Back on the top block, clamp it down in the mill and start milling out the middle where you will fit the bottom block into. Take good care that the tolerances are low, as the tilt head works on the principle of clamping the sides together so the top and bottom locks together. You only need to mill the size a few hundredths of a millimeter bigger than the bottom piece to give it a little bit of clearance. Onto the axis bolt, which is actually more like a carriage bolt. Turn down a piece of aluminum to a fraction below the diameter of the holes you drilled before. Again, this is to leave a little bit of extra clearance. Leave some material in one end. After parting the bolt off, turn it around in the lathe and round off the head of your bolt using files and sandpaper. In the mill, again break out the indexing head and put your bolt into that. Edge fine the inside of your bolt and mill down most of the head all the way down to the smaller diameter, retracting and turning the indexing head 90 degrees every time. Essentially, you're making a square end to the cylinder and a smooth head to cap it off. The square shape will prevent the bolt from spinning in its hole. Using a drill press, drill a hole through a piece of scrap wood the same diameter as your bolt. Holding a die with a pair of vice grips and cutting the threads while feeding the bolt through the wood ensures that the threads are started straight. After a couple of turns, you can remove the bolt and continue threading as normal. Fit a washer and wing nut to the end and call it done. Since you can't really fit a square peg into a round hole, regardless of how much you try, you need to file out one of the holes in the upper piece to accommodate for the carriage bolt. Take your time, it will be boring and a bit tedious, but through the magic of video editing, the hole got finished lickety-split. Lastly, you need to make some padding for the camera. Cut out some rubber to fit on the top of your head using the top plate as a cutting template. Remember to cut a hole in the center of the rubber for the thumb wheel to poke out of. Now, since you have all the parts, just fit them together. Rubber can be hard to glue, but it can be easily stuck down with some heavy-duty double-sided sticky tape. And you're done! Mount it to your favorite thing which has a tripod bolt and enjoy! I found this very useful for mounting my compact camera onto my combined hiking stick and monopod. As a reward for sticking with this build all the way through, here are some shots done with the aid of the miniature tilt head.
Oh, marshmallow exploded.
Thank you for watching! Be sure to subscribe for more antics from Switch and Lever. See you next time!